In this session of CCNA series, we will discuss SYSLOG protocol. It is really important to know how helpful Cisco devices attempt to be to their network admins. Those devices notify network admins in real time about any major or minor event that occurs on the device with detailed system messages called log messages. These system messages can vary from the very common to those that are extremely important. So in this session, we will see how those events are notified by the device to the administrators. As you know, we can access any network device either using console or remotely using telnet or SSH. In Cisco IIS, by default, any user that has logged in using console will see all severity levels of messages. That is due to the default logging console global configuration command. For remote users, you need to enable logging using logging monitor that tells iOS to enable the sending of log messages to all the logged users. The users must also issue the terminal monitor exec command during the login session, which tells iOS that this terminal session would like to receive log messages. So those two methods will let you observe the events only when you are around or logged into the device. So what if you want to store those events and keep the copy of those events later for observation? Interestingly, Cisco IIS provides two primary means to keep a copy of those logged events. IIS can store copies of log messages in the RAM by virtue of the logging buffered global configuration command. Then any user can come back later and see the old messages by using the show logging exec command. But RAM can store the information till the device is rebooted. If you reboot the router or a switch, it will be gone forever. So what if the router crashed, or you want to see if it has logged anything before it went down, or if you have dozens of routers and switches logging into each device one by one to look for syslog messages is also not the best way to spend your time. So if you have multiple routers and switches, logging into each device one by one to look for syslog messages is also not the practical way. The second option that is used frequently in production network is that all devices store their log messages centrally to a server. This server is called SYSLOG server. Now the question arises, what is SYSLOG? SYSLOG is a protocol that facilitates the transfer of log information from network devices such as switch router to a central server known as SYSLOG server. It uses UDP to send messages to SYSLOG server for storage. Any network device can send their logging messages to the server. So later a user can connect to a server, typically with a GUI, and browse the log messages. To configure the router or a switch to send log messages to a server, add the logging host using address or hostname global command. So referencing the IP address or hostname of the syslog server. Let's go ahead and look at one of the syslog message. This is the message when you have an interface down on your router. So let's take a closer look at one of the syslog messages. On the left, you'll see a timestamp which will tell you at what time this error occurred. Then we have the facility on the router that generated the message, that is percentage line protocol. This generates the message. This is the facility. Then we have severity level. We will discuss in the upcoming slide. Here the severity level is 5. Then we have a mnemonic of the message, that is up down. And then we have a description of the message, that is line protocol on this particular interface has been changed to down.
iOS assigns each message a severity level. So there are different severity levels for logging information. SYSLOG messages have 8 severity levels, which are denoted by both number and name. The lower the number, the more severe that event that caused the message. The top two level, emergency and alert, are the most severe one and will log any serious issue that require immediate action. The next three level, called critical, error and warning, will alert you about events that can impact your device. Then we have the next two level, 5 and 6. For in notification information is for messages that are more about notifying the user rather than identifying errors. And the last level is used for messages requested by the debug command, that is level 7. Of the 8 log messages severity levels, debug level 7 has a special purpose, because these messages are generated only when any user has enabled it using debug command. The debug exec command gives the network engineer a way to ask the router iOS to monitor for certain internal events, with that monitoring process continuing over time so that iOS can issue log messages when these events occur. That's it for this session. I hope this was informative for you. Thank you for watching.